So, hey, buddy, welcome back to the series name In a Search of Shooting a Cat, in which we are talking about something extraordinary about quantum mechanics in a form of a thriller story by which you can easily understand that what is happening in the series and how this happened. So, be with me in today's interesting thriller story name as The Clock in the Box and the EPR Paradox. Okay, from chapter 9 in the search of shooting a cat. So, what happened with these kind of like paradoxes? So, be with me in the story. I hope you enjoy. So, time, a relentless force, ticking away, never stopping. But what if we could trap it? What if we could defy the very limits of uncertainty and measure time itself? This is the tale of the clock in the box, and we are Dignity. Welcome to Dignity. Let's talk tech. So, the year is 1927. The world of physics is at war. At the center of it all, two titans, Albert Einstein and the man who redefined the gravity, Niels Bohr. Young physicists growing up with their magical experiments like the orbital motions of atom, the high precise of quantum mechanics, their battlefields, the fundamental nature of reality. Einstein had a problem with quantum mechanics. To him, it was incomplete, an unfinished puzzle full of contradictions. And so, he devised an experiment to expose its flaws. And what the experiment is, imagine a box, sealed, perfectly sealed, with only two tiny slits that opens for a fraction of a second. Inside a clock ticks with absolute precision a photon, a particle of light, escape through the slits. Like, listen to me carefully. It's an experiment. So, thought it is an experiment, a box, okay, which have two slits. A photon is passing through the slits by the clocking of time in a second. Photons is passing through the slit per second by second, like one photon, 1 second, second, second photon, okay. The weight of the walk changes, okay. A photon, a particle of light escape through the slits, okay. The weight of the box changes just slightly because one photon is out from that box, so a fraction of weight is loses because photon escaped. Like, okay, we know that photon have no mass, but it also consumes some kind of energy, so we have a loss of energy, so we have a change in the weight of that energy, okay. So listen to me carefully, just slightly, okay. If we measure the that weight change, we can determine the energy of that photon, okay. And with the precise timing of the clock, we can also determine the exact moment it left. So by this, the Einstein saying that we can measure the photon's momentum and like a weight, okay, the position at the same time. That's not possible, okay. So and then lay Einstein, okay. So listen to me. And then an Einstein challenge. If we could measure both the energy and the exact timing of as emission, Heisenberg's uncertainty principle would crumble. Quantum mechanics would be incomplete. Okay? So, but Niels Bohr was not open to be easily defeated. Okay? He saw what Einstein had missed, a flaw buried deep with the very fabric of reality. Gravity. Einstein's own theory of relativity would become back to hunt him. If we measure the weight of the box, we disturb it every slightly. Okay? If we measure the weight of the box, we disturb it so slightly. And according to relativity, this disturbance affects the ticking of the clock. The more precise, the more precisely we try to measure the time, the more uncertainty we introduce into the energy momentum, energy measurement. Bohr had done the impossible. Using Einstein's own theory, he had saved quantum mechanics from destruction. The clock in the box did not break the uncertainty principle. It confirmed it. And how? The battle was over, but the war raged on. Einstein would go on to challenge quantum mechanics again and again, but each time the strange probabilistic nature of the universe would prove relentless, resilient. Okay? The clock in the box, once a weapon against uncertainty, became a symbol of quantum mechanics, unshakable foundations. Today, we built atomic clocks that push the very limits of the time measurement. Quantum mechanics had led us to unbreakable cryptography, quantum computing, okay, and even the very fabric of our like reality's deepest secrets. And it all begins with a simple thought experiment: an old box, a ticking clock, and a battle between the greatest mind in the physics. Time moves forward, relentless and unwavering. But the question it leaves behind, the will echo through eternity. The clock ticks on and the box remains open. Okay, but the battle wasn't over. The clock in the box had fallen, yet Einstein was not ready to surrender. If he couldn't break quantum mechanics with uncertainty, he would challenge it with reality itself. And so, in 1935, the next move was made. An attack so profound it would shake the foundation of physics. This is a tale of ERP paradox. So, what is the ERP paradox? I will tell you. Be with me. So, Einstein, along with Boris Podolsky and Nathan Rosen, devised an experiment, a scenario so bizarre that if quantum mechanics were right, reality itself had to be wrong. How? Two particles, once together, now separated by vast distance. You know about this experiment, galaxy and galaxy. Two particles are like they are in the past they are together. Now they are separated and a vast distance. Like one particle is in another galaxy and one particle is another galaxy. Okay, so yet the moment you measure one, the other intensely respond. Okay, no matter how far they traveled, they remain connected, as if some invisible thread linked their fast across space. Einstein called it spooky action at a distance. What a distance. And if it were true, then information was travels faster than light and it's not possible in this world of relativity, according to Einstein, violating everything he had built with relativity. He refused to accept this. There had to be another explanation. And what is? A hidden force, hidden variables that determine the outcome before measurement. The universe had to be obey strict classical laws. But Niels Bohr, the champion of quantum mechanics, saw the argument differently. To Einstein, measurement was a passive act, like open a door to see what's behind it. But the Bohr, but to Bohr, measurement was the very thing that created reality. The universe did not exist in a definite state until it was observed. The whole quantum mechanics was all like exist on the observations. Without observation, everything, anything like also me does not exist in the quantum level if we don't observe it. According to Bohr, the entangled particles did not carry hidden structures, instructions from the start. Instead, their property weren't decided until the very moment once we measure. It was spooky action. It was the fundamental nature of reality to measure what to define existence itself. Okay, so for decades, the debate remained unresolved. But then John Bell proposed a way to test it. If hidden variables existed, certain mathematical inequalities should hold. But if quantum mechanics was right, those inequalities would be violated. The stage was set for the ultimate experiment, the verdict. Quantum mechanics stood vertices. The inequalities were broken. The universe was instead non local. Entanglement was real. Reality was stranger than friction. Okay, Einstein had tried to disprove quantum mechanics. Instead, he had to lead us to its greatest proof. And what proof? Today, entanglement is at the heart of quantum mechanics, cryptography, and very structure of the space-time itself. But what does that mean of reality? If entanglement is real, then what we call it, separation, is an illusion. The universe is not a collection of isolated objects, but a web woven together by forces we are only beginning to understand. Okay, the battle between Einstein and Bohr has ended, but the question they asked, they will never echo through eternity. The paradox remains. The universe remains unsolved. So that is about the EPR paradox and the clock in the box. I hope you enjoyed the story. Be with me for the next amazing story.